For billion miles from the sun, there is a small frozen world that keeps sending back data nobody can fully explain. Not glitches. Not errors. Real numbers from real instruments. And hit subscribe now, because this channel breaks down real space discoveries without the exaggeration, and there's a lot more coming out of the outer solar system you don't want to miss. To understand why this is such a strange result, you have to go back to where Pluto's story actually starts. In February of 1930, a 24-year-old lab assistant named Clyde Tombaugh was working at an observatory outside Flagstaff, Arizona, doing one of the most mind-numbing jobs in astronomy. Night after night, he photographed the same patch of sky, then flipped back and forth between plates, hunting for a single point of light that had shifted position against the fixed stars behind it. Most nights, nothing happened. Then one night, something did. A faint dot had moved, and that dot turned out to be Pluto. For nearly 75 years afterward, it was taught in classrooms as the ninth planet in our solar system, even though nobody had ever actually seen its surface. In 2006, the International Astronomical Union held a formal vote and reclassified it as a dwarf planet, stripping away the title that had made it famous. To this day, Pluto remains the only object in history to be discovered, celebrated for generations, and then formally voted out of the category that once defined it. For a long time, that vote seemed to close the book on Pluto. It got filed away as a small, distant, unimportant rock. That assumption did not survive contact with real data. Because here's the thing people forget. For most of the 20th century, even the best telescopes on Earth could only resolve Pluto as a tiny smear of light. Its orbit was well mapped, but its actual surface, its composition, whether it even had an atmosphere, remained open questions right up until a spacecraft actually got close enough to look. Some early estimates of Pluto's size were wildly overinflated, based on the assumption that it needed enough mass to explain small irregularities in the orbits of Neptune and Uranus. Those irregularities later turned out to be measurement errors, not evidence of a hidden giant world at all. In other words, much of what the public believed about Pluto for generations was built on guesswork stacked on top of more guesswork, which makes what came next even harder to have predicted. That happened in July of 2015. NASA's New Horizons probe, after a 9.5-year journey across billions of miles of empty space, screened past Pluto at more than 30,000 miles per hour. It had exactly one shot. No orbit, no second pass, just a few minutes to gather everything it possibly could before flying on into the dark, never to return. What it sent back rewrote the textbooks overnight. A massive, pale, heart-shaped plane stretched across the surface, strangely smooth and young-looking next to the ancient, battered terrain around it. Mountains built from water ice, frozen so hard it behaved less like ice and more like solid stone, rose more than 10,000 feet into a thin, hazy sky. And layer after layer of blue haze extended hundreds of miles above the surface, visible even when backlit by the sun. Pluto didn't look like a dead leftover chunk of the early solar system. It looked like a world still doing something. But New Horizons only got that one look. Whatever it missed on that single pass was going to stay a mystery, possibly forever, because there was no follow-up mission planned. What researchers actually needed wasn't a better photograph. They needed a way to read Pluto's chemistry directly, from millions of miles away, without ever launching another spacecraft. That's exactly what the James Webb Space Telescope was eventually built to do. Here's what makes Webb fundamentally different from something like New Horizons. Webb doesn't fly past anything and take a picture. It reads light itself, breaking it apart into individual wavelengths to reveal the precise chemical fingerprint of whatever it's staring at. Pointed at a faint pinprick of reflected sunlight 4 billion miles away, it can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how all of that changes over time, without physically going anywhere. The catch is that Pluto, and its largest moon, Charon, sit so close together in Webb's field of view that separating their individual heat signatures used to be nearly impossible. Earlier telescopes kept trying to isolate Pluto's atmospheric signal and kept coming up empty, not because it wasn't there, but because their instruments couldn't tell how much heat was coming from Pluto and how much was bleeding in from Charon right next to it. Webb's much larger mirror and far more sensitive infrared instruments finally solved that problem, and starting in 2022, once fully calibrated, Webb turned its attention toward Pluto for the first time. If you're the kind of person who wants space explained clearly instead of buried under jargon, go ahead and drop a like on this video right now. It genuinely helps this kind of content reach the people who'd actually enjoy it. The first result to come out of that data involves the same blue haze New Horizons photographed back in 2015. Scientists already knew Pluto had a thin shroud of hydrocarbon particles wrapped around it. What nobody had confirmed was what that haze was actually doing to the world underneath. Back in 2017, a planetary scientist working at the University of California, Santa Cruz proposed something that sounded backwards at the time. On Saturn's moon Titan, atmospheric haze traps heat and warms the surface below it. She argued Pluto's haze might be doing the opposite, absorbing sunlight during the day, then radiating that energy straight back out into space faster than Pluto's razor-thin atmosphere could ever hold onto it. Not a blanket, a radiator, actively bleeding heat away from a world that already had almost none to spare. Most of her peers weren't convinced, and there was no instrument sensitive enough to test it. That changed once Webb's mid-infrared instrument came online, and could finally separate Pluto's faint signal from Charon's. A research team working out of the Paris Observatory used that instrument to measure Pluto's atmosphere directly, and the results, published in a major astronomy journal in mid-2025, confirmed almost exactly what had been predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze suspended inside it, and it's running roughly 30 degrees Fahrenheit colder than earlier models predicted. Researchers are now describing this as a genuinely new kind of climate, one that doesn't behave like any other atmosphere we've measured anywhere else in the solar system. Pluto isn't simply cold because it's far from the sun. In a very real sense, it's actively refrigerating itself, and scientists are still working out how far the consequences of that reach, including whether similar hazes might be shaping the climate of Neptune's moon Triton, or even hinting at what Earth's own atmosphere looked like billions of years ago, long before oxygen ever built up in our sky. There's a second discovery tied to that same haze, quieter, but just as strange once it sits with you. Even the faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high in its atmosphere. Those fragments don't just disappear. They recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift down and settle onto the surface. New Horizons caught early traces of this back in 2015, and Webb has since helped refine exactly how the process unfolds. Here's the detail that tends to stop people. Tholins belong to the same broad family of organic molecules some scientists believe once rained down onto early Earth, potentially supplying raw material for the chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years straight. A slow, continuous snowfall of biological building blocks, landing on a surface too frozen for any of it to ever spark into something alive. To really understand how extreme the cold is, look at the raw numbers. Sunlight reaching Pluto is about 1,000 times fainter than sunlight reaching Earth, meaning high noon there would look closer to a heavy twilight here. Surface temperatures generally sit between about -387 and -369 degrees Fahrenheit, more than 250 degrees colder than the lowest temperature ever recorded anywhere on Earth. At those temperatures, nitrogen, The same gas that makes up most of the air in your lungs right now freezes completely solid. The atmosphere you're breathing as you watch this would, on Pluto, simply become part of the frozen ground. The third major finding is the one that tends to unsettle people the most once it's explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this. What they didn't know for a long time was where all that escaping material was actually going. It turns out something has been catching it. Pluto's largest companion, an ice moon called Charon, roughly 750 miles across, orbits in an extremely tight gravitational lock with Pluto. Most of Charon's surface is unremarkable, ancient, cratered water ice, except at its poles, which are stained a deep reddish-brown, darker than anything else on the moon. For years, researchers suspected a connection to material escaping Pluto, but couldn't confirm it directly. The mechanism turns out to be tied to Charon's brutally long seasons. Because of how it's tilted as it orbits, Charon's northern polar region spends multiple decades in complete darkness at a stretch. That makes the pole an extremely effective cold trap, a place where escaping methane drifts in, freezes solid simply because there's no warmth to keep it as gas, and sits there accumulating for years before sunlight finally returns. Once it does, the sunlight doesn't melt that frozen methane away. Ultraviolet radiation and cosmic rays break the molecules apart and reassemble the fragments into heavier, reddish compounds, permanently locking in that dark coloring instead of letting it evaporate. Two worlds, locked together, in a slow, ongoing exchange of atmosphere and color that's apparently been running since long before either one had a name. Charon had one more surprise waiting. In late 2024, a research team working out of the Southwest Research Institute used web data to confirm both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound, frozen directly onto Charon's surface. The carbon dioxide most likely came from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. That exact chemical combination had never been confirmed on Charon before. If you found this as strange as I have researching it, drop a comment letting me know. It genuinely helps me figure out what's worth covering next. Now picture, for a second, what it would actually be like to stand on Pluto's surface. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth. You could look directly at it without any discomfort. The sky would sit in a permanent grayish-blue gloom, thick with haze, never fully day, and never fully night. The ground under your feet wouldn't behave like ice does here. At nearly 400 degrees below zero, water ice stops being slippery and starts behaving more like solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe, though the cold would reach you and freeze exposed skin almost instantly, long before the thin air itself became the real problem. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each always shows the same face to the other, a silent standoff running for billions of years. The surface itself holds its own separate mysteries. In one region, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system. Tall rows of jagged ice blades, some over 1,500 feet high, made of frozen methane, arranged in long parallel ridges. Smaller versions exist here on Earth in certain high-altitude deserts, rarely taller than an average person, formed by sunlight causing uneven melting across an icy surface. On Pluto, that same basic process appears to have played out on a vastly larger scale over a much longer stretch of time. A 2025 analysis of the original flyby data suggests these ice blades may wrap around as much as 60% of Pluto's equator. Elsewhere, a massive dark region roughly the size of Alaska stretches across the equator, colored a deep reddish black, where those falling Nolan particles have piled up over billions of years on some of the oldest terrain on the planet. South of the famous pale heart-shaped plain, two enormous isolated peaks rise out of the landscape, and researchers still can't fully explain them. One stands roughly 13,000 feet tall, the other may reach close to 20,000 feet, with deep depressions at their summits that closely resemble cooled lava flows. Except there's no molten rock on Pluto. That internal warmth feeds directly into one of the most debated ideas surrounding Pluto today, the possibility of a hidden ocean, buried roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. The evidence isn't a photograph, it's a pattern. Cracks and ridges across the surface line up in ways that fit what you'd expect from a subsurface layer of liquid water shifting beneath the crust, and that pale heart-shaped plain sits directly above a gravity anomaly, a spot where something denser than the surrounding ice may be concentrated below. Similar hidden oceans are already strongly suspected beneath Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons, both of which show far more obvious surface evidence. If a body as small and cold as Pluto turns out to be hiding something similar, it would suggest buried oceans might be a far more common feature of icy worlds than scientists previously assumed. If that ocean genuinely exists, it's likely been sealed away for billions of years, cut off completely from sunlight and radiation, fed only occasionally by hydrocarbons seeping downward through cracks in the ice above it, sitting under enormous pressure in total isolation. It would represent one of the strangest possible environments in the solar system for the basic conditions life requires, existing without any direct connection to a star at all. Here's the detail that tends to stick with people longest. Pluto isn't unique just because of where it sits. It's inside the Kuiper Belt, a vast ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects and an estimated trillion or more comets. Beyond that lies the theorized Oort cloud, thought to hold another trillion icy bodies, stretching outward roughly a quarter of the way to the nearest star. The Kuiper Belt alone is estimated to span an area hundreds of times larger than the asteroid belt most people picture when they think of a field of space rocks, and unlike that belt, it remains almost entirely unexplored. Only one spacecraft has ever ventured deep enough to closely photograph any of its larger residents, and even that mission only managed close flybys of two objects out of the hundreds of thousands believed to exist out there. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of questions scientists are still learning how to properly ask. Out past Neptune, in the cold and the dark, there are trillions of other worlds we've barely glanced at. And if one small, formerly dismissed dwarf planet was hiding this much complexity underneath its surface, it's genuinely worth wondering what all of those other distant worlds might be hiding too. If stories, like this one, grounded in real published research instead of exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I'll see you in the next one.